Hello everyone, Mr. Fawcett here, and we're back with another Algebra 1 lesson. Today we are going to start solving equations. So we're going to start from the very basics. We're going to start with one-step equations. I know these are something you have certainly worked with in your middle school and pre-algebra courses. However, we need to make sure that we are completely proficient with one-step equations before we move on to two-step, before we move on to multi-step, before we move on to equations with variables on both sides. So today's lesson is probably going to be a lot of review, but I think you're going to pick up one or two unique things. We're also going to, maybe not today, but we will talk about one-step equations that you may not have worked with before. So maybe one-step equations with square roots or one-step equations with exponents, etc. So again, if this is review, that's okay. Make sure you know how to do all the problems we talk about. If it's not review, that's fine. That's why we're here. We're starting from the basics and we're going to build a very strong foundation because again, one of the most important things technically that you need to be able to do when you leave Algebra 1 is solve various types of equations. Okay, it's going to be important for geometry. It's going to be important for Algebra 2, for pre-calculus, and calculus. So you're going to be machines when it comes to solving equations when you're done with this course. That's my goal for you, and I want you to take pride in the fact that by the end of this year, I'm going to be able to throw you any type of equation. You're going to be like, Mr. Fawcett, no problem. I got it. I can solve it. Okay, I do want to make one analogy to what equations represent. So maybe you've heard this before, maybe you haven't, but in equations like a scale, right? One of those old balance scales where you put something on one side and you can balance it out with something on the other side. So explain, just pause the video, take a minute, explain why an equation could be like one of these old scales. What are the similarities between the two? Okay, so I just put that both equations and scales need to be equal on both sides if they are to be true or balanced, right? So with my scale, I need to have things on both sides that weigh the same. Now, they don't have to look the same, right? I could put a cat on one side and a dog on another side, and as long as they both weighed the same, the scale would be balanced. It wouldn't tip in favor of one or the other. Maybe I would need 3 cats to equal the weight of 1 dog, and that's okay as long as they both weigh the same. Equations are the same way, right? You may not see the exact same thing on both sides, right? One side may have an x, the other side may just have numbers, but for the equation to be true, the things or the quantities or the numbers and the variables on both sides of the equation must be equal to one another. If they're not, then the equation is false. So we're going to look at how we could balance scales and how that is related to us balancing equations using different operations. So for number 2, it says, what equation does the following scale represent? So we have some x's and we have some units on there. They just each represent 1. So take a minute, see if you can write the equation that that scale represents. I'm going to scroll up here. Okay, so on the left-hand side, we have an x, and we have 4 blue unit circles. So x plus 4. On the right side, we just have 8 units. And of course, the equal sign represents the middle of the scale. So we have x plus 4 is equal to 8. So think about the scale for now. How could we get the x box by itself? And again, I want you to think about this in terms of the scale rather than the equation. So what would you physically have to do with the scale to get the x on a side by itself? Okay, I think it's pretty clear. You'd have to take off these 4 units, right? And that would get the x by itself. Now, if we want to keep this scale balanced, right? If we take off 4 from this side, well, this side is going to shoot way up, right? Because it's going to be a lot lighter than the other side. So if we're going to take away 4 units from the left-hand side, we're going to have to pick 4 units to take away from this side. And it doesn't matter which 4 you choose as long as you take away 4. So we need to take off 4 units from each side. And then think about what this means we'll have to do with our equation from above. So if we have the equation x plus 4 equals 8, we don't have the actual physical, circles or balls to take off of our scale, but we can mimic that using a certain operation. So if we're taking away 4 from the side with the x on it and from the other side, right, well, that should be subtraction. So I need to subtract 4 from both sides. If I do that, well, I'm going to be left with just x on this side because the 4 simplified to 0, and I'll be left with 4 on the other side. And there's my solution, right? X is equal to 4. And you can think about this in terms of the scale. If I get rid of this x and I replaced it with 4 units, well, our scale would be balanced, right? I'd have 8 little unit circle-looking things on both sides, so both scales would be the same. We have some special names for what we just did. Let me erase some of this. Actually, just going to erase all of it. We're going to look down at the last question. So what do we call operations that we use to simplify out terms on one side of an equation? What must we make sure to do when performing these operations? So take a minute to try to answer this question, then come on back. Okay, so we call these operations inverse operations. Inverse operations. And again, these are operations that undo something. So again, if I rewrite my equation, x plus 4 is equal to 8, I needed to do an operation that undid the plus 4, right? I needed the inverse operation of addition. And the inverse operation is subtraction if we're talking about addition. So that's why I would need to subtract 4 from both sides, because subtraction, inverse of addition. Now, we'll talk about the inverses of the other operations when we get into some practice problems, but I'm sure you're already familiar with most of them. Now, the important thing here is, notice what I did in this step, right? I didn't just subtract 4 from the left-hand side, because that would not keep my equation balanced. I had to subtract 4 from both sides. So whenever you are performing an operation on one side of an equation, you have to do it to both sides. The only exception is if you are adding 0 to both sides, which we never really do, right? But if you add 0, if you add nothing to one side, you don't have to add nothing to the other side, because adding nothing doesn't change anything. Also, if you multiply by 1 or divide by 1. So there's a few circumstances where doing something to one side won't change anything, namely adding or subtracting 0 and multiplying or dividing by 1. But whenever you are doing any other operation with any other numbers, you must do it to both sides. If you don't, your equation is going to become unbalanced. So we need to say do these operations to both sides of the equation. All right, so we're going to head over and do some practice problems. We'll do one or two of each type of inverse operation just so we make sure we understand which inverse operations we need to use where, and then you'll have plenty to practice on your own. All right, so we are off to our practice. We're going to do numbers 1, 2, 3, and 5 together. Now, I would encourage you to try these out on your own, even though you'll have others to practice later, just to see what you remember from from pre-algebra. And you may not need any help, and you may just get them automatically, and you're good to go on. And if you do, that's great. And if you need that extra help by watching the video for the answer and explanation, that's also fine too. So number 1, we need to identify what inverse operation we need to do. So we need to get the n by itself, so we need to move the 1 to the other side, right? Or simplify the 1. So we need to use the inverse of addition, which is subtraction. So I'm going to subtract 1 from both sides. That simplifies. I'm left with n on the right-hand side, and I'm left with negative 10 on the, I hope I said right-hand side for n. I think so. And I'm left with negative 10 on the left-hand side. Negative 9 minus 1 is equal to negative 10. I would also strongly encourage you guys to not use your calculator here. There may be a couple on here where for some multiplication or division, the numbers are larger and you may want to check it with your calculator. But for all intensive purposes, most of these can be done using mental math, or maybe you just want to work it out on paper. There are times to rely on our calculator, but in general, I'm pretty big on trying not to use it whenever you can, just to develop a better fluency with numbers, right? If we're always reliant on our calculator for addition, subtraction, multiplication, and division, it's just like it's like a weak link in our armor for math, right? We're not as strong as we could be. So if you're not very good at doing these operations in your head right now, just take some practice. By the end of the year, you'll become much, much better at it. Okay, number 2. This time we have a little bit of a different equation, right? We have x being divided by 13. So the inverse operation of division is going to be multiplication. So we need to multiply both sides by 13. Okay, that will simplify my denominator here, and I'll be left with x is equal to 9 times 13. And again, this would be one of them where it's like, okay, it's going to be a large number, but try to do it in your head, right? 10 times 13 would be 130. So 9 times 13 is 117. So x is equal to 117 here. Next one we're doing is 3. We have negative 12v is equal to negative 168. So we have v being multiplied by negative 12. Well, we just said for number 2 that the inverse of division was multiplication. That also means the inverse of multiplication is division. So I need to divide both sides by negative 12. Don't just divide by 12, because you have to simplify the negative as well. So on my left-hand side, my negative 12 simplify, I'm left with v. On my right-hand side, I have a negative divided by a negative, so I automatically know that my answer is going to be positive. Negative 168 divided by negative 12 ends up giving me 14. And again, maybe it's something you take a guess at and then you check yourself with a calculator. No harm in that. The last problem we're going to do, because number 4 is similar to number 3, we are going to do number 5. So let's clear this and then let's go to 5 and we'll be done with this video. Okay, so 5 is a little different. It says b plus negative 8 is equal to 0. So we have to think, do I need to use addition or subtraction to simplify the negative 8? Well, we need to look at the sign of what we want to simplify. In this case, we want to simplify the negative 8. So we need to add the negative 8 to both sides. This equation is really the same as b minus 8 is equal to 0. They mean the exact same thing. And if it helps you to rewrite it like this, go ahead and do that. But you also need to understand that you could see an equation like this and you need to know what to do. So again, either way, we're going to be adding 8 to both sides. Oops, let me get my pen, not my eraser. Just going to do both equations. So for my left equation, the negative 8 and the positive 8 simplify, and I get b is equal to 8. And of course, I do the same thing over here. b is equal to 8. So however you want to think about the equation is fine, but in either scenario, you're going to be using the inverse operation, that is addition. Okay, quite a few problems to work through, but these are quick because they are all just one step. If you find yourself doing multiple steps, you're doing too much work. So all of these can be solved with one inverse operation and one only. Okay, next time we are together, we will continue to look at some slightly more complicated equations to solve. We're going to gradually build our way up. So enjoy the rest of your day, and I look forward to seeing you next time.